In part F, we have f of x equals tan x times sine x. We see we're using the product rule. So I separate out the two factors, take the derivative of both. And I see that f prime of x equals sine x times secant squared x plus cosine x tan x. Again, I look for where we have this multiplication of different trig functions. I see that sine x times secant squared x is the same as sine, actually let's change the color here. Sine x times secant squared x is the same as sine x times 1 over cosine squared x, or 1 over cosine x times cosine x. Well, I have then sine x over cosine x times 1 over cosine x, which is the same as sine over cosine is tangent, and 1 over cosine is secant. So sine x secant squared x is actually tangent x secant x. Let's look at the second highlighted form. I have cosine x tan x, but we know that tan x is the same as sine x over cosine x. Cosines cancel, leaving me with sine x. Thus, I see that f prime of x is actually sine x plus tan x secant x. Okay, for g, I'm given f of x equals x over x squared plus 1. I want to use my quotient rule. I separate out the numerator and the denominator. I use my quotient rule and find that f prime of x equals 1 times x squared plus 1 minus 2x times x all over x squared plus 1 squared. So f prime of x equals x squared plus 1 minus 2x squared all over x squared plus 1 squared, which equals negative x squared plus 1 all over x squared plus 1 squared. Now I can look at problem H, where I have f of x equals cosine x over x squared. Again, I'm using quotient rule. Separate out my numerator and my denominator. Take the derivative of both. And use the quotient rule. So I find that f prime of x equals negative x squared sine of x minus 2x cosine x all over x squared squared, which gives me a negative x squared sine x minus 2x cosine x all over x to the fourth. I realize I can factor out a negative x from the numerator. Which leaves me with negative x